Okay, let's take a look at number 37 then. Okay, let's see, suppose that PQ is a focal chord of this parabola. Okay, and it tells us that the coordinates of P are 2, 4. Oh geez, that was really poorly drawn. Okay, so there's P. Okay, there we go. And it's going to pass, it's a focal chord, so it has to pass through the focus. And because we have this information, we know where the focus, because we know the equation is y equals x squared, right? And so then we know that 1 is our coefficient, that it's going to equal 1 over 4p, so p is going to be 1/4 here. So, right, 1/4 is going to be my distance, so my focal chord is going to go like this, and q is going to be way down here. Okay, so since I had my coefficient, I can figure out what p is going to be, right? And that does definitely help there, right? Getting started with that one. Okay, so find the coordinates of q. That's what we're trying to find here. Okay, so we know that the focal chord, right, PQ is a focal chord, okay. Right. So if I'm taking a look at this, I know that where this point is going to be. I know that the focus is on this, right? The coordinates of the focus are 0, 1/4, right, from what we have there. I know the coordinates of this point are 2, 4, right? I can get the equation of the line and see where that line hits that point. So the equation of the line, let's see, the slope, 4 minus 1/4, right? 4 minus 1/4, right? 2 minus 0. Rather than making fractions, I'm just going to scale everything by 4 here. Right? Scale everything by 4. Right? To get 16 minus 1, so it's getting 15 over 8. Okay, you would have gotten the same thing if you made, if you subtracted it. Right? So my slope is that, and I'm going to just I don't use it very often, but I'll use a slope-intercept form because it gave me that. Okay, so there's that line, and it's going to hit this, right? This is the intersection, so I can just take this and I can say, okay, right, 15 over 8x plus 1/4 needs to equal x squared for myself, and that's going to give me those coordinates right there. So where is that going to be? Okay, so if I'm going to scale everything by 8, so that I don't have to deal with all these fractions. Okay, and looking at this and my factors then, and this actually helps because I know that 2 is going to be one of my answers. Alright, so I'll make that one of them, and what's left over, 8x plus 1. Hey, look, that works out. Alright, and so I knew which one of these was going to be, so that does help me to get the other one there. Okay, so I have my x value is -1/8. I know we have 2, and that's the other one I have. The x value is -1/8. I plug it in there. I can plug it in either one. I'm just going to plug it in there. It's easier. That's 1/64. So, right, there's Q, and there's part A done. Okay. Part B, find the coordinates of M, the midpoint of PQ. Okay, well, that's really just finding this midpoint is, okay, if we have P, and that's at 2, 4, and this is Q at that point, we just average those two. So the average of 2 and -1/8 is going to be, so 2 plus -1/8 divided by 2, and 4 plus 1/64 divided by 2. Right, and you just work that out. I'm going to do the same strategy I did before. Multiply by 8. Right, so it's going to be 16 minus 1, so it's 15/16 there. Right? Is that right? So 16. I multiplied everything by 8, so 16. Yep. Okay. And hold on, let me just check my work rule. Okay, good. And so over here, I'll multiply by 64. So 60, so that's 256, right? 257 over 128. Of course, right? Oh, geez, everybody knows that, right? Okay, so there's my part B. Right, so there's part A, there's part B, which is my coordinates to the midpoint. Okay, so let's start with the next one. Okay, so for this next one here, so we have our M right here. Okay, so we're drawing two perpendiculars. So a line perpendicular to the focal chord is drawn through M. So it's perpendicular focal chord, right? That's M, right? And it's going to go up here, and that's going to hit at T. Okay. Now the other part was I thought was a little confusing. A line perpendicular, perpendicular is drawn from M to the y-axis. So we have a perpendicular right here, and that's going to be S right here. So that's perpendicular, and that's perpendicular right there. Okay. Find ST and verify that it's equal to 1/2 the length of the focal width of the parabola. Okay. So if we're going to look at that, now we know what the coordinates of this are, right? So because we know the coordinates of this right here, we know that this right here, this is going to be 15/16. So SM because it's perpendicular. Okay. We know that for certain, right? Because that's just the x value coming off of it. Okay. We know what this length is here, 257 over 128. Okay. So what we could do right here, and I guess we have a couple options here. If we think about our triangles here, we can use geometric means for this because these are all right angles. So this is 15/16. This is 257 over 18, or sorry, 128. Okay, we could do Pythagorean theorem to get that length right there, but actually we don't really need that. We can just use the geometric mean. So these two triangles, are similar to each other. Okay, this and this are similar to each other because we have right triangles there. So we could set up that 257 over 128, right? Which is, if I put some angle measures on here, that'll help me to see what's going to, that's going to be the 15 over 16, as 15 over 16 is to this length right here. Okay, and when I do that, I get 257 over 128, x equals 225 over 256. Right, x equals 225 over 256 times the reciprocal. Hey, those cancel nicely, so we get 225 over 257 times 2, right, or times 1/2. Sorry, right. I'll put that just like that. Okay, and then all right. So find ST. So that's ST right here. That's the first part there. Okay. And verify that it that is equal to 1/2 the focal width of the parabola. Okay, so well, let's see, the focus was right here, right? The focus was at 0,1/4, so the focal width was 1/8. I must have messed up somewhere. So this isn't 257 over 128. This is actually, we're going to have to subtract whatever the 1/4 is, because remember this is F right here. Okay, so I had a mistake right here. So we're going to go back, right, and I'm going to fix this. So I'm going to splice this out, hopefully, of the video, right, so you won't see it. But so I got to take 257 over 128. I got to subtract the 1/4 from it, right? Not the easiest thing in the world, and I'm just going to go to my calculator just to make it easier, because of in the interest of time. Okay, all right, so that's going to give me 225 over 128. Okay, so that's going to be 225 over 128. Okay, so when I 225 over 128. Okay, when I cross multiply here, right, for myself, well, actually before I cross multiply, I can then reduce these, boom, boom, right, and so I can see for myself that instead, what am I going to have? I'm going to have 256x equals 128. Hey, that's going to be 1/2 there. Okay, so ST is 1/2. Now, if we look at it, right, verify it's equal to 1/2 the focal width, right? So this was 1/4 here, right? So if I'm thinking about the focal width for myself, how far is this going to be? Okay, that means we're going to have the directrix here. So in all, that's 1/2 apart. So this is going to be 1/2. So that's 1/2 here, and that's 1/2 there. And so this focal width here is 1, and that is 1/2 of it. So there we are, done with that part.